Hi everyone, I hope you can see my screen. My name is Rino and welcome to this live presentation. Today's topic will be a general overview of Urbano functionality, something like a best of to highlight the various possibilities of Urbano. Like Michael said, Urbano is software for detailed design, analysis and hydraulic calculation of storm and sanitary, as well as water and gas distribution networks. Over the next hour, I'll show you how to import from Google Maps, how to draw the network in plan and profiles, how to run hydraulic calculation for both water distribution and storm networks, how to run clash detection analysis, how to import pipe networks from various file formats such as EPANET and EPA-SWMM, as well as AutoCAD elements like polylines and also Civil 3D objects. So let's get started. In this first example, we will draw, design, and calculate one water distribution network. So as you can see in this drawing, we only have this raster image, but even if you don't have any raster, you can always download it directly from Google Maps. So this is what I will first show you. If you go to tools, we can go to import from Google Maps, and there are two ways how you can import. First way is by going directly to Google browser, and here you can search for the area of interest. For example, this is in Croatia, place called Novi Vinodolski, and you can see this is the matching area. You can select it and you can download just one map and also points with elevations for that area. If you want to download multiple maps, you can do it as well, but you have to go to the second option, and that is the option to select the area directly in CAD. To do that, you have to select the coordinate system. For Croatia, this is the one for this area. And now you can select a polyline, draw the area, or select the current view. I have here on a hidden layer one polyline, which will be my area of interest, and I will select that polyline. And now I can define a zoom factor. The higher zoom factor will result in a higher number of rasters that will be downloaded, and the smaller zoom factor will result in the less number of rasters. And of course, more rasters will result in higher quality picture. So let's download 4 maps. Also, I will use this polyline to create clipping boundary. And also, like I said, you can import just raster, just points, or both. Because I already have DTM surface for this area, I will download just rasters. So let's click import, and in a matter of seconds, these 4 maps will be imported in AutoCAD. You can see that the map matches the existing map that I have in this file. You can see the streets and everything matches perfectly. Okay, now I will switch again the layer states to show you the DTM. So these are the source elements. You see the 3D points, contours, and stuff like that I use to create this Civil 3D DTM surface. So if I pick on it, you can see it's a Civil 3D surface. And it is important to say that Urbano is basically AutoCAD application. It works on plain AutoCAD, but if you run it on top of Civil 3D, you get these additional features. For example, you can use DTM surfaces from Civil 3D directly, and also you can import and export with Civil 3D gravity pipe networks. Everything else is completely the same. If you run Urbano on top of plain AutoCAD, you have our own DTM modeler, which is called Terraform, and I created using the same source elements also the surface with Terraform, and you can see this is the purple one. Basically, they are completely identical. So it's up to you if you want to use Civil 3D or Terraform surface. Okay, let's now start with the designing of this network. So this will be one small network. Here it will be a water tank. We will design interactively by drawing in plan one pipeline from the tank to the distribution network. And this will be our distribution network that we will convert from these plain AutoCAD polylines. It can be also lines. So we will convert that to network. So let's do it. First, I will go to draw function. And here in this dialog, you can set up many different options. For example, we can automatically read terrain elevations from the selected DTM surface. And like I said, it can be Civil 3D, it can be Terraform, and also it can be plain 3D face objects created with some third software. I will go with Civil 3D. Also, from the pipe catalog, you can select pipe. I will go with PEHD pipe, 250 millimeters. And you can also place the pipe to be on a constant depth below terrain. Also, you can include labeling of nodes and sections. So let's click draw. And now I will use AutoCAD OSNAP to connect to these helping circles. You can see that you can draw freely without any constraints, or if you want to draw using the angles, fixed angles, you can use this so-called compass function where you can create these angle configurations. So you can define which angles, deflection angles, are available, and also combinations of these angles are available when drawing. So for example, you can use the all angles, you can turn off some angles, create your own configurations, and so on. So for example, let's go without 30 or 60 angles. And you can see that this compass appears, and you can draw only using those angles. If you want to turn this option off, of course you can, and you can continue drawing freely. So these are straight line sections, but if you want to switch to curved sections or arcs, you can as well. So you can again draw the arcs freely without the defined radius, or you can set the fixed radius by selecting it from the drop-down list or by typing the custom radius, for example, 50 meters. And now you can see that you are fixed to that radius. So let's continue drawing, and I'll be switching from arc to line section and then back to arc section. And you can see that each new element that I draw, they are automatically tangent to the previous section. And also you can see that how I am drawing, the terrain elevations are being automatically read, and also the pipe is being placed on a constant depth below terrain. And you can see that in the labels that are being automatically placed in plan. So this is it. Here I will stop drawing like this. And now I will switch to the next function, which is conversion of CAD element. So let's go again to draw, conversion of CAD elements. And here you can see that you can set up all the same options as in the previous dialog. So we will use the same DTM surface, the same depth below terrain, same labels, but this time I will go with smaller pipe. I will use 110 millimeters for this distribution part of the network. Also, this is a great function because you can filter out some elements. For example, I will select these elements in plan. The software recognizes which layer this is, and now I can freely select the entire drawing, and the software will select only the elements on selected layer. So now when we convert it, everything is converted from plain AutoCAD objects to intelligent Urbano objects. So now I don't need these helping layers anymore, so I will turn them off so we can focus just on the Urbano network. So if we zoom to plan, we can see we have some blocks which represent the nodes or junctions. It can be, of course, custom blocks. Also, you can show the pipes as single line, or you can show them like this in a 2D style. And you can see these are plain AutoCAD lines. They are not some custom objects. Okay, so this is it. And also you see the labels that we have that of course can be customized as well. And you can see that up to this point, we placed everywhere 250 millimeters, and below everywhere is 110 millimeters. The best way to analyze Urbano network is by using data tables. And here in the workspace, you can see that basically all functions in Urbano have this so-called configurations, as we call them. So configurations are basically predefined sets of data options settings for each function. So you have multiple configurations for data tables, for labels, for profiles, and so on. So when we open data tables, you can see that you can switch between these configurations of data, and you can preview your network. You can show the entire system, or you can use the selection options. For example, I will go to selection of sections or pipes. So basically links between the nodes. So I can select, for example, these 3 sections, and here it is. We have only data for those selected in the data table. Also, we have much more intelligent selection options. For example, selection of branches. So you can see what is a branch in Urbano. Basically, everything in between the main node, so starting or ending or branching node. And if I select, for example, these 3 branches, I will get all the sections that belong to those branches. But also I can switch to a different data table with different data for branch geometry, and now I can see the total data for the entire branch. And also we have some topology selection option, which is called array. And array is basically arbitrary sequence of elements that the user can create. So you can join these arrays, you can break them, and basically create your own topology. So by default, one AutoCAD polyline is one array, and also what you draw in one run, what I draw here, is also one array. So for example, if I select these 2 arrays, I will get all the sections and all the branches that belong to those arrays, but also I can switch to a different data table showing me the data for the entire arrays. Also, like I said, you can merge those arrays or break them. So let's go to editing of the arrays, and I will merge these 2 into array A1. Okay, and now if I go to selection of arrays, you can see this is one single array. Other than for previewing, these data tables are great because you can use them for data inputting or data editing. So all the cells that are white can be edited directly through the data table. For example, you can use it for renaming of the elements. But for renaming, I prefer to use the options for renaming. So let's go to edit, and I will use this option, rename arrays according to rules. This is a great function. You have many different rules, and I will use this one according to hierarchy. So let's select the main array, and we will say, okay, the main array name is A1, and all other arrays will be renamed automatically according to hierarchy. So let's click rename, and notice in the data table, what does that mean? So we have A1, then the one that connects to it is A11, then we have 111 and 112, 12, 13, 131, 132, and 14. So we have the whole network structured like this. So now that we know everything there is to know about the Urbano topology, let's draw profiles. And why I showed you this is because in Urbano, when you draw profiles, you don't have to have alignments because the profiles are drawn directly for the pipe elements. And this is why Urbano profiles are so easy to use. So basically, all you have to do is have your configuration, which you can create once and use on all of your projects. Everything is stored here, from the language to the data to the colors, scale, everything. So just select it. And now I will draw profiles for the entire network. And now I can select if I want to draw them according to arrays or according to branches. So let's go according to arrays. I will place them in 5 rows and 2 columns. And when I click draw, I get these 9 profiles drawn for the entire network according to this array topology. Of course, also I can draw them from node to node interactively. So we can go from any node to any node in any direction. I will go all to this last node of the network. And let's place it here. So now if we take a look at the profiles, we can see that we placed the pipe to be on a constant depth below terrain. But of course, in Urbano, you can edit this pipe position precisely using many different options, using the data table, or even drawing or editing directly in profiles. To do that, I will use also one helping tool, which is really nice. And those are these auxiliary elements, and I will use them to draw terrain parallels. So I will do it for all profiles, 1 meter and 3 meter below terrain. So let's click draw, and these helping lines can now show me if I am somewhere too deep or too shallow below terrain. Okay, and for editing of the pipe, I will use this function. So input and edit pipe invert, which can be used even for drawing or for editing. And you can use it for drawing or straightening by line or by slope. So for example, let's go from this node to this node, and I would like to just straighten it by line. You can define starting or ending depth or elevation, or just click apply, and you are straightening this pipe by line. Also, let's go to the next segment. I will go from this node to this node, and now I will increase the depth in the ending node, for example, from 1.5 to 2 meters. And now I will click apply. So this is straightening or drawing by line, but also you can go by slope, where you can define starting or ending, depth or elevation, and slope. So let's go, for example, with fixed slope of 5 per miles. Let's click apply. And now if I see in the data table, we have the constant slope of -5 per miles. Okay, so this would be it regarding the editing of the pipe position, but as you can see, there are many different options to precisely define your pipe invert position. I will also delete these helping lines now. Okay, the next thing would be to set air release and washout valves. To do that, I will switch to Hydra panel, and I will open the function for air release and washout valves. Here you can, of course, select nodes manually in plan or in profile and define air release and washout valves for them, or you can select the entire network and use the automatic option and click apply. And basically this function searches for the highest and the lowest inflection points in your network. So basically where the slope is changing from negative to positive or positive to negative, and is automatically placing this air release and washout valves. You can see that the custom blocks appeared automatically in the profile. And also if I zoom to those same nodes in plan, you can see that the custom blocks appeared in plan as well. If you want to place those equipment in some kind of manholes or structures, you can do that as well. So let's go to function for setting of the manholes. From the manhole catalog, you can choose between many different types of manholes, so different shapes, different sizes, different materials. I will go with this rectangular manhole, and also I will select the entire system, but I will use this node type filtering to select just air release valves. So click save, and you can see that now all the air release valves will be inside of a manhole. Let's do it for the washout valves as well. Save, and that's it. And additionally, I would like to place a manhole everywhere where I have this so-called main node, so where I have branching in my network. I will use this main or plain node filter. So main, entire network, save, and I have now manholes in all the main nodes as well. If I now zoom to profile, you can see that the manholes automatically appeared in those positions. Okay, now I would like to switch to a different drawing, which is basically, you can see the same drawing, but here I have some stuff predefined so we can move a little bit faster through the presentation. Here, I would like to first set a water tank into the first node of the network. So in the Hydra panel, I will go to hydraulic node equipment, where you can set all the EPANET available node equipment, such as reservoirs, tanks, pumps, valves, and so on. So let's select this first node, and I will set it up to be a tank with all the default settings from EPANET. I will click apply, and notice that the custom block automatically appeared in plan and also in the profile as well. The next thing would be to set water demands. So let's go to function for setting water demands. And here you can see that you can use many different methods for defining water demands. And now I'll show you just the two most commonly used methods. The first one is so-called percent calculation, where you can define water consumption per inhabitant, let's say 180 liters per day per one inhabitant. And also you can define the number of people living on some area. And for selection, you can use these selection options from Urbano that I showed you, or you can even use CAD selection. So I will select just this distribution part of the network, and I will click Save. And you can see that all the water demands are automatically calculated and distributed to the nodes in the selection. And the other way how you can set water demands is by using point demand. So basically just select some nodes in plan or in profile like this. And now you can set the same value to all the nodes in the selection, or you can go directly through data table and define different values for each node. I will reset this because I would like to just set one node demand in this node here. Let's say it will be some kind of industry here that needs 6 liters per second. And this will be our basic water demand to hydraulically size this network. So if you remember in the first example, I defined pretty roughly everywhere in this part pipe of 250 millimeters and everywhere else 110 millimeters. Now I will go to pipe optimization function, which uses genetic algorithms to search for the optimum pipe diameters based on the target velocity. So in this function, it is recommended to separate your network into some kind of zones or groups, which I already did. So I divided my network into transport pipeline, which is this part here, and distribution network. For each group, you can define target velocity, and you can define it as a single value or as a diameter dependent value. So this is the option that I will use. And also for each group, you can select from the pipe catalog which pipes are allowed to be used in that group. So now when I click Start, the software is searching for the optimum pipe diameters so that the real ending velocity in the pipes is as close as possible to the defined target velocity. And here you can see even the data, what is the difference between the real velocity in the pipes and the target velocity. So now the calculation is done. You can save it, or you can preview it before saving. So for example, let's select this array and this array. And you can see that if we see these differences between the target and real velocity, you can see that in some pipes here, close to the, in this part, we have ideal solution. So difference is 0. But the more we go to this ending, dead ends of this branch network, you can see that we have some bigger differences. But of course, this is because the software placed the smallest pipe that we selected that is available. So I will save these results. Okay. And we can now take a look at the results. You can see that the piezometric lines automatically appeared in the profiles, and also the plan automatically updated. So you can see that the labels automatically updated. You can see we have now different pipe diameters, and also the dimensions of the pipes in this plan style also automatically updated. Let's now include the hydraulic calculation results in the labels. So I will just apply the default labels that I set for this drawing. And now you see flows and velocities and also pressures and piezometric lines appearing for all the nodes and the sections. Like I said, the best way to analyze results is always by using the data tables. So let's switch to section hydraulics, and we can see the velocities. And like I said, in this dead ends of the branch network, we have some smaller velocities. But if we take a look at the highest velocity is around 0.80, which is great for these pipe diameters. Also, if we switch to the node hydraulics, we can see that we have some pressures that are really small, but they are all happening here outside of the distribution network close to the water tank. And if we check for the highest pressures, we can see that the highest pressures are happening because of the very steep terrain in this bottom part of the network. And we will take care of this by placing one pressure reducing valve. But another great way how you can analyze these hydraulic calculation results is by using the thematic maps. So I will apply one thematic map for sections for velocity and also pressures for the nodes. Additionally, I will place these pressure contours, and you can use the same ranges as we used for the pressure theme map, so the legend can apply for both. So let's click draw. And now I will split my screen so we can simultaneously see both the plan and the legend. And now graphically, you can analyze where you have places of the higher pressures and also places where you have smaller velocities. So like I said, the only logical solution would be to place one pressure reducing valve to this node here. So let's do it. So I will delete these thematic maps. I will remove these pressure contours, and let's go back to Hydra panel, hydraulic node equipment. I will select this node and I will place one pressure reducing valve with the reduced pressure setting of, let's say, 35 meters. Let's click apply. You can see that the custom block automatically appeared in the plan, but the values didn't change. That is because we have to rerun the hydraulic calculation. So let's go to hydraulic calculation. Now, according to the existing diameters, and I will just click calculate. Notice that each time you click calculate in Urbano, this EPANET EMP file is created. So if you need it, you can open it. If you don't need it, you don't have to. But this is IMP file, which means that you can open it with EPANET, but also you can open it with any hydraulic modeling software like Bentley or Infoworks or basically any software because it's a worldwide standard. So let's close this and I will just save the results and notice that the labels automatically updated. So now the pressure is exactly 35 meters, which can also be seen here in the profiles in these piezometric lines. Okay, now I would like to switch to the third drawing where I will show you, so I'll show you how you can export to EPANET, basically to IMP file, and I will show you how you can also import from IMP file, which can be from EPANET, but it can also be from these other softwares that I mentioned. So now we have one more complex network in EPANET. You can see that we have two water tanks, we have two pumps, we have one flow control valve, and also what can be seen is that we have these so-called polyline sections, polyline pipes that can also be imported in Urbano. So here we have a blank drawing. Let's go to Hydra panel, import from IMP file. We selected the file, and now I will import the pipes from EPANET to Urbano catalog, but basically it will create a dummy catalog because you know that in EPANET you only have the inner diameter, and also I will write this diameter data to this custom data one, which I'll use later to bind with the real Urbano pipe catalog. I'll show you later. Regarding the elevations, if you have, you can use DTM surface, or if you don't have, like I don't have in this drawing, I will just set the constant height above the pipe, constant cover of, let's say, 1.5 meters. So let's click import. You can see that import is really quick, and you can see we have the water tanks, we have the pumps, we have the flow control valve, everything is here, as well as these polyline sections that you can also draw. I didn't show this. You can of course draw them or import them from the external sources. Okay, let's now draw the profiles for this network. I will select the entire system. We will draw it according to arrays, but when you import from somewhere, by default, one array will equal to one branch. But like I said, you can merge them and create your topology. So let's click draw and let's place those profiles here. And additionally, I will draw one more profile using the option from node to node. Let's go through this node here and let's place it here. Now, if we take a look at the profiles, we can see all this equipment. So water tanks, pumps, valves, everything is here. And now what I told you before, so if you take a look at the pipe, you can see that only data that we have is the data from EPANET, which is inner diameter. This can best be seen if we open the data tables and switch to data table for the pipes. You can see that the program created this dummy catalog with the inner diameters from EPANET. Material is unknown, and nominal inner and outer diameters are all the same value, and wall thickness is everywhere 0. But like I said, we can go to this great function, binding the data with the catalogs. So in custom data 1, I imported the inner diameter data. And now if I know which pipes these are, I can see that we have some ductile iron pipes, we have some PhD pipes. I can connect them to various pipe catalogs. And what is great is that you can create these binding rules, you can save them and use them on all of your projects. So just I will click run. And now notice that the pipes will automatically be connected to Urbano pipe catalog. And you can see we have some ductile iron pipes, we have some PhD pipes, we have real pipe diameters and real wall thicknesses, which can also now be seen in the profiles. Okay, let's see what else did we imported from EPANET. So if we go to Hydra, network elements data, like I already showed you, we imported 2 tanks with all their data from EPANET. We imported 2 pumps with their pump curves. We imported the valve with all its parameters. And also, if we go to water demands, we can see that also water demands are imported. We can see where those water demands are defined. So basically in this bottom part of the network. And we have everything to go to hydraulic calculation. And just click calculate. Like I said, EPANET IMP file is created again, but we don't need it. So just click save. And you can now analyze the results in basically in AutoCAD, because you have all the EPANET results now available in Urbano. So you can analyze it like this in profiles using the piezometric lines with their data. You can analyze it through the data tables or even through the labels. If we apply the hydraulic calculation results to the labels, here it is. All the labels are now showing you the hydraulic calculation results. Okay, I'm moving to the next example, and now we are done with water distribution networks. Let's go to storm networks. It is basically the same for sanitary as well. So you can of course design, and like I showed you in the first example, design process is basically identical for drawing in planning profiles. The only thing that differs are the calculations, because for water distribution network, we are using EPANET, and for storm and sanitary networks, we are using EPA SWMM. So you can draw and export, of course, but also you can import from IMP files. So here is one storm network. You can see the catchment areas, you can see the rain gauge, everything is defined. So let's now go to Canalis panel, and here let's go to import IMP file. Again, we have the blank drawing. We selected the file. We will import the pipes to catalog and also to custom data 1 if you want later binding. And regarding the elevations, identical. If you have DTM, you can use it. But now, if you want to use the elevations, you can use them from EPA SWMM. But you know that there is no terrain elevations there. So we will calculate it based on a bottom of the manhole elevation and the maximum depth of each manhole. So I will use this option. I will import. Again, you can see that the import process is very quick. We get the network, we get the catchment areas. Of course, you can draw them in Urbano as well. So let's label. Again, I will place the default labels that are set in this drawing for nodes and sections. Let's also apply the labels for the catchment areas as well. And now if we take a look, we can see all the data that we imported for the catchment areas and also for the nodes and sections. We see terrain elevations and also invert elevations, and also we see this this outfall that is set in the last node of the network. Let's now draw profiles. I will use this configuration. I will draw for all the arrays. Like I said, when we import, the array equals to branch. So in total, 85 profiles. Let's place them here. You can see that the profile drawing is extremely fast because it works on topology and not on alignments. And also let's draw one from node to node. Let's draw it from this node, let's say all up to the outfall here. Let's click draw and let's place it here. Okay, now if we take a look, we can see that we have the pipes, we have the manholes, everything is set. And you can again see that we have only the inner diameter data. And if you want to have the real pipes, you can use the bind data function, but I will not repeat it, not to repeat myself. Okay, but let's see what else did we import. So if we go to rain gauges, we can see that we imported one rain gauge with its series. We can also show the time series. So it is basically one time series with the 40 minutes data of the rain with the constant rainfall intensity of 140 liters per second per acre. Also, we can go and check the subcatchments data. So you can see that everything, basically all the EPA SWMM available data for the catchment areas, you can define it, you can edit, but we imported everything. And also, if we go to network elements data, we can see the outfall and all its data. So basically, we have everything to just run the calculation in Urbano. If we take a look at the options dialog, we can see that we imported the options from EPA SWMM as well. And we will do a time analysis of 2 hours with reporting and run of steps set to 1 minute. So let's calculate. And we will also save the results. And notice that we have 120 sets of results for nodes, for sections, and for catchment areas. When I have so many results, I like to switch to preview by object. And then, for example, select one node, section, or catchment area. I will select the last section close to the outfall. And when I sort it by flows, I can get the peak flow for that section, which is happening at 46 minutes of the simulation. So I will apply those times. So 46 minutes, let's click apply. And now those results are applied in the drawing, in the profiles, in the labels, in the standard data tables. So if I now go to profiles, you can see that the water levels automatically appeared in the manholes and also in the pipes. Okay, so this would be it regarding the hydraulic calculations. And now we will switch to something completely different, and that is intersection analysis, or basically clash detection functionality, which is really great in Urbano. And in this drawing, you can see that we have 4 different pipe infrastructure systems. Here in the legend, you can see which systems these are. And they are basically all happening on a very small area. So there will be a lot of pipe crossings and also potentially a lot of pipe clashes. So let's analyze that. To do that, first I will draw the profiles. So we showed this functionality many times. So I will select the entire network according to arrays. Let's click draw and let's just define where we would like to place those profiles. And notice that the intersections, as we call them, meaning pipe crossings and pipe clashes, are completely automatic in Urbano. So all you have to do is draw your plan, and in profiles, the labels and the relative positions of the cross pipes will automatically appear. Of course, you can change the appearance of the labels. You can select the data. What would you like to see? Basically, everything can be customized. But the point is that everything is completely automatic and dynamic. So I will also show you the profiles of the other 3 systems that I drawed before, but I have them on a hidden layer. So let's restore those layer states. And you can see that it's the same for all 4 pipe networks. Now, if you need more data about the crossings and clashes, you can go to special panel for intersections, where you have all the functionality regarding this pipe crossings and clashes. The best function to analyze this is this intersection preview, intersection data table, where you can see all the crossings and clashes in this table view. And when you pick on it, you are automatically zoomed to that crossing in plan. You can see all the data in the data table. So which systems these are, which pipes these are, what are their nominal diameters, or basically some other data. You can have different data configurations. For example, you can see the coordinates of the crossing, terrain elevation, station, and so on. And also it is not just pipes with pipes. You can go to pipes with manholes and also manholes with manholes. Let's now go back to pipes with pipes, and let's also analyze one very important data, and that is relative position. So you can see exactly which pipes are above or below selected pipe, and also you can see which pipes are in direct collision. So this is very important because you always want, for example, for your water distribution networks to be above your sanitary system pipes. Also, if you want to focus just on the clashes, you can filter to see only collisions. So now we can see only collisions. And also you can zoom to profile if you want. So you can zoom, for example, to sanitary profile and see the crossed storm pipe, or you can zoom to storm profile and see the crossed sanitary pipe. So really nice functionality. If you want to include some tolerance, you can. So let's increase the tolerance to, let's say, 10 centimeters. And now you can see all the pipes and also all the manholes that are located on a 10 centimeters or less distance. Also, what can be done, let's turn this off. You can analyze these crossings and clashes in 3D. Because this distance you see here, this is the distance calculated in 3D. So if we now zoom to data table, we have our pipes and manholes shown in 3D, and this is the shortest distance in 3D calculated between the two crossed elements. So let's go through the data table, and you see all the elements. And also if we go to pipes with manholes, it is the same. You have the shortest distance between the two elements. Okay, let's now turn off 3D. Let's go back to plan view. And now I would like to show you how these crossings are completely automatic and dynamic. And to do that, I will just draw quickly one new system. So let's say this will be a water distribution network. We will start drawing. This time I will use terraform surface. I will place the pipe to be on a constant depth below terrain. I will select PEHD pipe of 110 millimeters, and I will say that the top of the pipe is 1 meter below terrain. So let's click draw. Again, I will use AutoCAD OSNAP to snap to these helping circles. And notice how the terrain elevations are automatically read from the selected DTM surface. And also in the background, the software is automatically calculating the intersections between the pipes. So you don't have to calculate anything. You don't have to analyze anything. You just go to drawing of the profiles, place the profile where you want to have it. And this is it. You have all the pipes that are crossed with your newly designed network. You see the data, so distances, terrain elevations, and intersection point stations, or basically any other data. I showed you today many different profile configurations to see how everything can be customized and looked completely differently. Okay, and now I would like to split my screen so we can simultaneously see both plan and profile, and we will focus on this part here, which is in plan, this part here. And notice now what will happen when I move a node. So if I move this node here, notice that the old crossings will automatically disappear and new crossings will automatically appear in the profile. So that means that everything is completely automatic and dynamic. Okay, so this would be it regarding the crossings and clashes. And now I will switch to the last example today, which is the process of import and export with Civil 3D gravity pipe networks. So this that you can see on the drawing is not Urbano anymore. This is a Civil 3D pipe network. This is a Civil 3D DTM. And also if we zoom to plan and if I select a pipe here, we can go to pipe properties. So this is Civil 3D gravity pipe network. And also you can see Civil 3D profiles. Okay, I will zoom to this part here. And now let's split our screen so we can simultaneously see both Urbano and Civil 3D. Here in Urbano, you can import from Civil 3D using two different ways. So first way is by using import and export from land XML, and this is a great functionality, but it is just import and just export. There is no update. And if you want to have update, basically live connection between both models, you can use this specific functionality, but in order to use it, you first have to bind catalogs. So this is a function where you can see on the left Urbano pipe and manhole catalog. In the middle, you can see Civil 3D structure and pipe catalog. And on the right, you can see the connected items. So basically, I connected in front all the pipes and all the manholes. And if I pick, for example, here on this connection, we can see, okay, so this pipe in Urbano is this pipe in Civil 3D. And it is the same for the manholes as well. So everything is connected in front. Okay, so now if I go to import from Civil 3D, I can import from current drawing or from external drawing, which has to be opened. So I will select this one, and I will say that I will import this to this empty sanitary network that I have here. Also, you can create a new network if you don't have any. Here in this drawing, I also have the same Civil 3D DTM surface, although you can use the data shortcuts as well. And this is it. I will just click import, and here it is. We have the same network now in Urbano. Let's label it. So I will use the default nodes and section labels. You can see that we have some label overlapping here. Of course, you can move it manually, but I will use this automatic label reposition so that all labels are automatically analyzed and moved, so there is no more overlapping. You can see 52 labels have been moved. Okay, so now we have the matching situation. So let's now do some editing in Urbano. First of all, I would like to increase this pipe from 300 to 400 pipe. And I will do it for the entire branch. So let's go to branch selection. I will select this entire branch and I will increase it to 400 millimeters PVC pipe. Let's click save. Notice in the plan that the labels automatically updated. And also I will do one major change, one bigger change so we can see it visually. For example, I will just move this node like this here. Okay, so let's now export this to Civil 3D. As you can see, everything is connected. The models are connected. So just click export. And on the right, you can see that everything automatically updated. We can see that Civil 3D pipe labels updated for the entire branch to 400. And also this node is now moved here. So let's now move this node, but let's make a change here in Civil 3D. So I will place this node back to its original position like this. And now in Urbano, I will just click to import from Civil 3D, import, and the node is back on its original position. Okay, let's now continue in Urbano. Again, I will draw the profiles for the entire network according to arrays, but like I said, arrays equals to branches because we imported from Civil 3D. Let's draw it. And again, you can see completely different scale, different visual appearance. The next thing I would like to do in Urbano, I would like to set trenches and calculate excavation calculation volumes. So to do that, let's go to input data for the trenches. From the trench catalog, I will select a trench, so you can define different types of trenches, different bedding, different sizes, different angles, with or without formwork, and so on. So I will set this simple trench with sand bedding and formwork, 90 degrees angle, to the entire network. You can see that the trench automatically appeared graphically in the profile. And also I will set this so-called top layer. So basically this is the layer on top of the terrain under which your pipes are going. So you can precisely define different types of the top layer, but I will just set for the entire network 50 centimeters of asphalt. Let's say that the network is going everywhere below the, let's say, 2 layers of the asphalt. To see these trenches and top layers better, let's draw some cross sections. And to draw cross sections, it's very simple. Just like for the profiles, everything is stored in these configurations. So you can draw them interactively by selecting some stations in plan or in profile, or you can select some parts of the network, for example, these 3 arrays. And let's draw automatically cross sections every, let's say, 25 meters. So let's click draw, and I will place this 31 cross sections here, and you can see how it's very quick and very easy to get them. And all these hatches, all these colors, all these dimensions and data, everything is stored in the cross section configuration. So now that the trenches are set, let's also calculate excavation report. We will group it by arrays. Let's click save. And in a matter of seconds, this Excel report will be ready. So we can open it and we can analyze it. So you can see for each section, you have starting and ending station, total excavation volume for the entire section. You have depth excavation zones, which you can set by yourself. You see the data for the upper layers, sand or concrete bedding, pipe volume, backfill layers, formwork area, and surface area of the trench on top of the terrain. And you can see that the report is grouped by arrays because this is how we defined. But if you go on the bottom of the report, you can see that we have what is most important, and that is the sum of data for the entire system. So now that these values are calculated, for example, if you need them in Civil 3D, let's do that as well. I will go back to this, we call it BIM panel. Let's go to data configurations. So here you can create data configurations that you can use on all of your projects, and you can use it for export to IFC, Navisworks, NWC, and Civil 3D as well. So here we have group for trench excavation data that I will export to Civil 3D. So let's go to export to Civil 3D. And this time I will include this export property set data, and I will include this trench excavation data configuration. So just click export. The Civil 3D model appeared on the right. And now if I pick on any pipe, so geometrically we didn't change anything, but we changed the data. So if I pick now on this pipe, and if I go to properties, under extended data, we can see the Urbano trench excavation data group with all the excavation calculation volume calculated in Urbano. Okay, and the last thing that we will do here is we will export this model to IFC. So let's go to IFC export. It is important to say that we are using the latest IFC standard, which is 4.3. You can select what DTM surfaces and what systems you would like to export. You can select which data groups you would like to export with the model, for example, geometry data and trench excavation data. You have to select the IFC base point, but let's pick any point in the network. And when you click export, this IFC will be created and you can open it in any IFC viewer, or for example, Autodesk Navisworks if you use it. And I will open it in Navisworks. So this is it. You can see the Civil 3D DTM surface that we exported, as well as this Urbano pipe network. So let's hide the surface so we can focus on our pipes and manholes. And if I select a pipe and go to properties dialog, here you can see the geometry data group and also trench excavation data group that we calculated with Urbano. So this would be it that we prepared for today. Basically, like I said in the beginning, the best of everything. And now, before we go to Q&A, I'll give a final word back to Michael.